Welcome. Today we're going to learn to factor simple quadratics. Quadratics, a lot of them, come by multiplying binomials together, binomials being two terms. So let's go one direction. I'm going to first show you how we get the quadratic, and then we're going to show you how to go back the other direction. What I mean by that is, we often get quadratics by multiplying two binomials together. A lot of times there will be a constant that goes into all the terms. And so let's multiply these together using either the distributive property or the FOIL method. A lot of people remember FOIL, first, outer, inner, last. I like to just think of it as the distributive. I didn't spell that right. Distributive. You get the idea. Where we're going to take the x, multiply by x, get x squared. That's the first times the first. Multiply the first times the last. We get a negative 3x. Then we're going to multiply the last times the first, or the inner ones, which is going to give us a 5x. And then the last times the last, or the outer ones, or not the outer ones, the last ones. And that's going to give us a minus 15. That's still needs to be multiplied by this leading 3. I have two like terms that I can combine, so I get an x squared plus 2x minus 15 that still needs to be multiplied by 3, and then I distribute in the 3 as a last step, and I get 3x squared plus 6x minus 45. Now, that's actually not what we're doing. What we're doing is we're going to be given this, and we are going to want to get back to that. So again, the first thing you always try to do when you're trying to factor a trinomial or a quadratic is to look for anything in common with all three terms. And if you'll notice, 3, 6, and 45 all have a factor of 3. So that would be our first step, is to say, let's factor out a 3. 3x squared divided by 3, or factoring the 3 out, leaves me an x squared. 6x divided by 3 leaves me a 2x. Negative 45 divided by 3 would give me a negative 15. So that's the first step. So we've got back to this. Now what we're going to do is realize where we got the negative 15 from. We got the negative 15 here from multiplying these two together. Where did we get the 2? By adding this negative 3x and 5x. And not a negative 2, it's a positive 2 actually. And we got the positive 2 by, in a sense, just adding these two terms together. So what you do is you, off to the side here, I'm just going to take that negative 15 and I'm going to start looking at its factors. Like, for instance, I know negative 1 times 15 does give me negative 15, but if I add them, I don't get 2. So then I go, okay, let's try negative 3 and 5. Hey, if I add those together, I do get a positive 2, and multiplied give me a negative 15. So again, multiplied together, those give me a negative 15, but negative 3 plus 2 gives me, or plus 5 I mean, gives me a positive 2, which is the middle term. So what we do now is we do two sets of parentheses. I have an x in front, and then I take those two factors I found, that minus 3 and that positive 5, and I put minus 3 plus 5, and I get my factored form. Now it's all right that I had the x minus 3 in front instead of the x plus 5. It doesn't matter the order we multiply, so I factored it correctly. So again, what the process was looking for two numbers that multiply to give you the end term, but add to give you the middle term. Whoops, this end term after we factor out the greatest common factor. Let's do one that we don't know the actual answer to and see how that works. So let's try something like, and we're going to use a different variable because you'll see all sorts of variables when you do your homework, 2u squared plus 20u plus 48. Well, again, what's in common with all three terms? Well, I see that a factor of 2 is. So I factor out a 2, get a u squared plus 10u plus 48 divided by 2 is going to be 24. Now, off to the side, I take this last term, this 24, and I start to factor it. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then I say, all right, since it's positive, they'll both be positive. Since the sum needs to be positive, they're both positive. And now I'm going to say, all right, 1 times 24 is 24, but 1 plus 24 is not this middle term of 10. That doesn't work. 2 times 12 is 24, but 2 plus 12 is not 10. That didn't work. 3 times 8 is 24, but 3 plus 8 is, again, not 10. That didn't work. 4 times 6 is 24, and 4 plus 6 is 10. That's the one that works. So I come over here and I do 2 sets of parentheses. I leave that 2 out front. Make sure you don't forget there's that 2. And then I do a u plus 4 and a u plus 6. And say we're both positive. And I factored my quadratic. And again, it would have been perfectly fine to do the u plus 6 first and the u plus 4 second. That would have also been perfectly fine. So that's factoring simple quadratic functions, is being able to factor out that greatest common factor, and then to be able to find two numbers that multiply to give you the end number, that's 24, and add to give you the middle number of 10. Now, you will run across some that are a little more complex than that, because that common factor might not come out. I mean, it won't be a common factor. And what I mean by that is, again, I'm going to first go one direction. Let's give you, let's say, 2x plus 7 times x minus 5. Okay, well, I'm going to go 2x, my first times my first. It's going to give me a 2x squared. My first times my last is going to give me a minus 10x. My last times my first will give me a 7x. And my last times my last will give me a negative 35. The two middle terms combine. I have that 2x squared as the first term, minus 3x minus 35. So now if you'll notice, there's not a common factor in between all these. There's this 2 that doesn't factor out. Well, when you're given these, normally either the 2 or the 35 will be a prime number. Usually one of the two numbers at the beginning or the end will be prime, which means there's not too many combinations you have to try. So what I do is I put a 2x and an x, and then I just have to think about this 35. Now be careful, don't come over here and go negative 35 and find factors that go. So the factors of negative 35, by the way, are 1 and 35, 5 and 7. But don't try to find 2 that add to 3, because we got to take into account there's this 2 out here. So what I normally do is I take these factors and I write them in. I go, okay, let's write a 1 here and a 35. I'm also going to try it in the other order, 35 and 1. And then I'm going to do the 5 and the 7 and the 7 and the 5. So what I'm doing is I'm picturing these as that third term. So then I ask myself, 2 times 35 is 70. That's the first times the last. But 70 added to 1, because I'm finding the two middle terms is what I'm doing if I plugged a 1 here and a 35 here. But the 1 and the 35 didn't work. That was 71. If I do the other direction and rearrange it, I'm going to get 36. That doesn't work. Now if I do the 5 and the 7, oh, by the way, one of these has to be negative, right? I didn't even think about making one negative. But 2 times 7 is 14. 5 times 1 is 5. And then 14 and 5, can I make that to be a negative 3 by making one of them negative? I can't. So that didn't work. So then I'm going to try the 7 and the 5. I'm going to go to the 2 times the 5 is 10. This 1x times 7 is 7. The 10 and the 7, I can get to be a negative 3 if I make the 10 the negative. Well, that tells me the 5 needs to be negative, because that's where I got this 10. I got the 5 from multiplying the 2 and the 5 together, and I want it to be negative. So negative 5, and then the 7 plus 7. And I get this expression. But you notice how I just had to actually just try each one. So let's try one of those that we might have not know how to do. So let's do this one. Let's do 8w squared plus 11w plus 3. Now again, there's no like terms in between all three. I can't factor away the 8. But this last term is prime. So what I'm going to do is realize that I only have so many possibilities. I have a 1 and a 3, And now I'm going to take that 8 and break it up into its either 1 and 8. So it'll either be a 1, and I should maybe do a 1x and an 8x, or it could be an 8x and a 1x, could be a 2x and a 4x, or it could be a 4x or a 2x. Remember, because the order might matter. So now I'm just going to keep trying them until I find a sum that gets 11 when I multiply by the 1 and the 3. So in other words, that first term, if it was an x times 3, would give me 3x. The 1 times the 8 would give me 8x. And if I add those two together, do I get 11x? I do. Actually, I should be using w, not x. So I happen to get the right one right off the bat. If I'd done one of these others, it wouldn't have, one of the other combinations, it wouldn't have worked. If I did 8x times 3x, that's 24x. And 1x, that's the 1 times the x, that's 25x. That didn't work. 2x times 3 is 6x. 1 times 4 is 4x. Add those two together, that gives me 10x. That didn't work. 4x times 3 is 12x. And then 1x times 2x is 2x. Again, add those, that's 14x. That didn't work. I just happened to get the right one right off the bat. So I know this should be an x plus 1 and an 8x plus 3. And there's my factored form. But you notice how I just wrote the two prime factors of the 1, and then I wrote the combinations out underneath, and then I just tried each scenario. Okay, one last scenario, and then I'll let you get to work. The one last scenario is sometimes you're given what's called a perfect square. I guess you could call it a perfect square, but what I mean by, well, it's actually the difference of two squares. If I gave you something like 3x plus 5 times 3x minus 5, let's FOIL this together. 3x times 3x is 9x squared. 3x times a negative 5 is going to be a minus 15x. And 5x times 3x is going to be a plus 15x. And 5 times negative 5 is going to be a negative 25. Now, these two middle terms, you notice what they do? They cancel. Negative 15x plus 15x is 0x. So I'm left with just a 9x squared minus 25. Well, what I want to emphasize is these two are perfect squares. What I mean by that is, 4, 9, 16, 25, 36, 49, 64. They're all perfect squares. So you can say, oh, I like this. If I want the middle term to cancel, I got to have the exact same middle terms and one positive, one negative. So what I'm going to do is I'm going to square root each of these. Square root of 9 is 3, so I do a 3x and a 3x. Square root of 25 is if I put a 5 and a 5. And then one has to be positive and one has to be minus. And you go back to your original expression. So let's do an example where you might not see it exactly. And they might give you something not too difficult, but they might give you, let's say, 16x squared minus 1. And it's always a minus, by the way. It'll never be plus. Well, again, all you're going to do is do two sets of parentheses. You're going to square root the 16. That's going to give you a 4x in both the front and the bottom. You're going to square root the 1, and that's 1. It's a perfect square. I should have put that in this list up here, that 1 is actually our smallest perfect square, right? And so I put a 1 and a 1, and then I put a plus and a minus. And that should allow you to do today's homework. If you have questions, please bring them to class.